Hello, I'm James Lehman, and this is going to be a series of tutorials on LaserBoy, the application, and how to use it and how it works. So, first thing, if you look here, this shows you the contents of the zip file. When you get the zip file and you unzip it to your hard drive, you'll get a folder called LaserBoy, and this is pretty much this right here is what's going to be inside of that zip file. And you might want to notice these directories here. You might want to notice these directories here because the way LaserBoy works, because it is platform independent, it runs on Linux, it runs on Windows, it runs on other operating systems as well. The file system it can only read and write to the space within itself, within its own folder. So if you want to bring a bitmap into LaserBoy to open it up, like to trace over it or something, you have to put it in the bitmap folder. Or if you have Ilda files from some other source, you have to put them in the Ilda folder. Now, inside the Ilda folder, you can in fact make another folder and put Ilda files inside of that, and LaserBoy can navigate into one folder deep inside of the Ilda folder. So like if you have a project that you're working on and you want to keep those files separated from other Ilda files, you can create a folder and put the Ilda files in that folder, and LaserBoy can navigate into that folder and open those Ilda files or save Ilda files there, either one. When you generate WAV files, they're going to be here in the WAV folder. And DXF also. If you have a single DXF file, you want to put it in here, and you can open a single DXF file in LaserBoy as a frame, or you can create a directory here and you can put a whole bunch of DXF files into that directory, and LaserBoy can open the directory full of DXF files, and it will create a frame set from that in alphanumeric order, in the order in which the DXF files appear inside the folder that you put in here. Okay, so but basically the main takeaway is that everything happens inside of these folders right here. So getting files into and out of LaserBoy is going to be through these directories in one form or another. Also, you get all the source code, which is, there's about 78,000 lines of code, active code actually. That's not counting comments. That's actual active code. Plus there's make files for a variety of different operating systems and variations on the makefile executable that you can make. LaserBoy comes with two executables that are already compiled. Both of them are for Windows. There's laserboy.exe, which is a 32-bit application, and there's laserboy64.exe, which is a 64-bit Windows application. Okay. And something that's really important here is, okay, I'm running Ubuntu here, and this is my command prompt right here. So when I run LaserBoy, I run it from a command prompt, okay, and this right here is the Linux executable of LaserBoy that I had to build. This does not come with the distribution, so if you're running Linux, you have to make your own executable, which is not very difficult. There's instructions actually. But you'll notice here I'm running the executable and I'm passing it two command line arguments. This is 1440 by 1080. And what that means is this is how many pixels wide and this is how many pixels high it's going to open the window when the LaserBoy executable is initiated. And if you're running a Windows machine, there's laserboy.bat. This is a batch file. You can open this in a text editor. And basically what this does is this calls laserboy.exe with the arguments of width and height. You can see that if you edit this file. And so laserboy.bat runs laserboy.exe, which is the 32-bit version, and laserboy64.bat runs laserboy64.exe, which is the 64-bit Windows version. And my suggestion for people who want to run LaserBoy on their Windows machine is it's a good idea to find out what your actual screen resolution is so that you have some idea of how to size the window that LaserBoy opens when it comes up. These numbers here, which in this case happen to be 1440 by 1080, this is the size of the field of space that's inside of the window when it opens. Now the window still has what they call Windows decorations around it. In other words, it has a thin border around the sides and the bottom, and it has a relatively thick title bar on the top of it. So if you know your screen resolution, you probably want to subtract about 80 pixels or so for the Y value, or the height of it, to allow for the thickness or the height of the title bar that goes across the top of the window. Because when you open LaserBoy, you want it to open full screen, and you don't want any part of it to go off the screen, because pretty much every pixel inside of that window is something important, something that you want to see when you're running LaserBoy. Okay, so like I said, check out this batch file or this batch file if you're running it on Windows, and set your width and height in pixels accordingly. So I'm going to go ahead and fire this up. Again, it's in Ubuntu, but it's the same difference. It looks the same on any operating system. And boom. Okay, first thing it does, when LaserBoy first opens, the very first thing it does is it opens this file right here, in.ild, which comes with the distribution. Okay, every time LaserBoy runs, it opens in.ild is the very first thing it does. And this screen right here shows you what it found in that Ilda file. It found 20 3D frames, which are Ilda format 0. It found 56 2D frames, that's format 1. Didn't find any of these formats, but it did find the Ilda end of file marker. It found one of those. So basically this designates that it just opened a legitimate Ilda file with this number of each section in it. And it'll do this anytime you open an Ilda file. You'll get this screen telling you what you just brought in to the LaserBoy memory space. So we hit escape and we come right into the main menu. And as you can see here, we're running it at 1440 by 1080. And it says welcome to LaserBoy, and it gives you the current version right here. If you are not running the current version of LaserBoy, when LaserBoy opens, it will tell you there is a newer version available. And I would highly recommend that you go ahead and download that. And you can find where it is if you read the readme.txt file that comes with LaserBoy. It'll tell you where to find the current version of LaserBoy. It's always a good idea to do that, because I find issues and I fix them. I add new features, whatever. So like if you're reading some kind of current discussion by me probably about what LaserBoy can do, chances are it might actually be pertinent to the most current version of LaserBoy. So you want to make sure that you have that, so that we're all on the same page. Okay. All right. Now, one of the things LaserBoy does rather well is it shows you what's going on. What we're dealing with here is we just opened an Ilda file. Okay. Well, an Ilda file is a binary file, and it can contain any number of individual frames of color vector art. And the frames can be two-dimensional or three-dimensional, meaning they can have just XY coordinates, or they can have XYZ coordinates in them. And these coordinates are stored in signed short integer, which is a computer data type. It's binary. It's a binary number. And for those of you who know what it is, fine. For those of you who don't, an integer is a number that can only represent whole numbers. In other words, when you're dealing with integers, there are no fractional parts. There is no 1.5. There's only 1 and 2. There are no points between the points. There are only integer values for points. And because you only have 16 bits and it's signed, there's a limited range of coordinate locations that you can count using 16-bit numbers. It's kind of like the odometer in your car. When you get to 99,999, the very next one rolls the whole thing over and you start back at 0 again. Well, binary integer numbers are kind of that way too. A 16-bit binary integer number, signed 16-bit, can only contain as high as 32,767. And 0 is considered a positive number, which it isn't really, but it kind of is. So because there's an even number of things that you can count with a 16-bit number, actually there's one extra negative value than there are positive values, because I said 0 counts as a positive value. So if the number line starts at 0 and goes positive this way, it goes to 32,767. And in the negative direction, it goes to negative 32,768. Okay, LaserBoy knows about that, and it manages that situation. So you actually cannot store a coordinate in the location of negative 32,768. And the reason is because if you could store a coordinate on this side of the frame in the negative space, and then you were to do a mirror image of the frame and flip everything, there is no corresponding positive value for 32,768. So LaserBoy just says you can't use that. So that's something to know. And when you're dealing with LaserBoy, LaserBoy doesn't sugarcoat anything for you. It presents things to you in the exact terminology and in the exact number systems in which it exists. So you do kind of have to have an understanding of the size of space, the fact that it's finite, and the fact that it's integer, and that you can only go to 32,767 in the positive direction and negative 32,767 in the negative direction, which, and I'll show you here, it forms, get rid of this, it forms a cube. All right, there's the cube of finite integer space. Nothing can be stored in signed 16-bit short integers outside of this cube. These are the absolute boundaries of space itself. Okay, three-dimensional space. Right. So, a few things that, as I said, LaserBoy is very good at showing you things. So you're actually looking at a very high resolution space here. From this side of the cube to this side of the cube, there are 65,535 coordinate locations along any three of the cardinal axes. And if you want to see the cardinal axes, they look like that. Okay? There's Z, there's X, and there's Y. And these tags, X, Y, and Z, are on the positive ends of these axes. Now these axes, they're not actually part of the art. They're just visually there to help you see the orientation of the art. So when you spin things around and you're looking at it from different angles, you can always kind of get an idea of where you are based upon the location of these axes. Okay. And again, in the user interface visuals, you can do things like turn on the vertices. Vertices is the plural of vertex, okay? A single point is a vertex. A set of vertices is vertices, that's plural, okay? A vector is the line that you get between one consecutive vertex and the next. So this line is a vector, this point is a vertex, okay? And there are other things that you can see here, like if you want to turn on fixed bounds, that's option A. This shows you the boundaries of space if you were not to have changed the camera view in any way. In other words, you're looking straight into space at normal zoom and no rotation. This is what the boundaries look like of that space, okay? Same as with the fixed origin. Boom. The fixed origin is now here, okay? There's the origin. Now it happens to be lining up with our other origin. I mean, I can rotate, whoops, hold on a second. I can rotate this thing and see this origin doesn't, the fixed origin doesn't change. The floating axes are moving around, a rotation. The fixed boundaries of space don't change, but the floating bounds are moving around to show you where the limitations of space are. Now, when I'm moving the camera around like this, I'm not changing the art in any way. All I'm doing is changing the way it appears on the screen, or your view of it, right? Another thing that you can see is the blanking path, right? So I'm going to turn some things off so you can see it a bit more clearly. Okay. So, all right, and boom. Okay, so, and boom. Now we're back to normal. Okay, this gray line here, that is the blanking path. What that means is when a laser projector would draw this or scan this for you, it's going to scan this lit segment until it gets all the way through it from the beginning to the end of it, and then the laser is going to turn off. The scanners are then going to move to another lit segment. Lasers are going to turn back on again, and the scanners are going to trace out this lit segment. The lasers are going to turn off, and the scanner is going to move again. Lasers turn back on and draw another lit segment. Okay, so here you can see in this particular frame, it's two-dimensional. As you can see, it is flat. Okay. It's 2D frame, happens to be the 0th index in the frame set, and there are 34 individual lit segments in this frame separated by blanking, and there are 494 vertices in this frame. Now, this art, as we're looking at it, is stripped down to the bare minimum essential points that actually create this drawing, this illustration. This is not what you would call optimized art. This is minimized. So this is going to take up as little space in an Ilda file as possible because it's only those points that are necessary to represent this image. There are no extra points in this to control the velocity of the scanners or to allow the scanners to settle on a point before they go ripping off into a different direction. There's no lines, there's no points to control velocity along the blanking lines. None of that stuff is here yet because we haven't optimized it. This is minimized vector art, okay? Now, let's talk about what we already looked in, okay, from the main menu. If you tap the enter key, it makes the menus appear and disappear for the most part. That's true almost all the way through, okay? All right, so with the menus up, okay, you can see here is U is the user interface visual. So if I hit U, I come into this menu here, and in here I already showed you, I can turn the vertices on and off, I can turn the blanking path on and off. Intro, bridge, and coda have to do with how frame sets get optimized and saved to a WAV file, so that's part of the optimization process of a WAV file. Indices is kind of interesting. I'll show you what that means. If I use the left and right arrow keys, I can go through the frames by index one at a time. You see here, right here, frame index is changing, and it's indicating this is a 3D frame. So if I spin it around, whoops, if I spin this around, see, it is in fact three-dimensional. All right. Okay, so this is a 3D frame, index 23. The indexes start at 0, so the 0th index is actually the first frame. So when you get to here, this is the 9th index, but this is the 10th frame, if that makes sense, because things start at 0. What I wanted to show you that's kind of cool is if you show vertices and blanking. Now you can see how this is this zigzag thing so that the laser can get through all of these lines in this particular drawing. If you turn on option 6, it shows you the numbered indices in this frame. This is the 0th one. It starts here. There's the first, this is the 0th index, which is the first vertex in the frame. This is the only vertex in the frame that can only be an anchor. it isn't the destination of anything because it's the first one. It's where this image starts. So it's the 0th index. This is the first index. This line is the first vector in this drawing or in this image. And then we have a blank vector, and then this is the second vertex, and then a lit vector and the third vertex, and so on. And you can see here there are 48 vertices. If you count all the way around from 0 to 47, that's 48 vertices, and there's 27 segments, which kind of makes sense, particularly in this drawing, because each one of these segments is nothing but a straight line, and a straight line only needs to be designated by 2 points, the origin or the anchor and the destination end. Okay? So that's kind of a cursory glimpse of what goes on inside of a frame. It is a list of ordered vertices starting at 0, going to however many there are in a single frame. Now, okay, back to the whole view thing of what's going on. Okay, the top row of the keyboard, I'll just go into, I'm from the main menu. Okay, here's something that's important. If you don't know where you are, keep tapping the escape key until you get to this bright red screen. And if you type yes here, this will terminate LaserBoy. LaserBoy will shut down. But if you type the escape key again, or any other key for that matter, it'll just take you back to the main menu. And you can see if you hit the return key, there's the main menu appears. You hit return, it disappears. So back here, we're looking at the main menu. From the main menu, we can go into V as in Victor, or View, and it'll show you what's going on with the camera or the view, okay? And as I said, the whole top row of the keyboard, the digits 1 through 8, they basically control the orientation of the camera as far as its rotation around the art is concerned. So if I press and hold the digit 1, it's going to roll around the x-axis, okay? Right. Let me turn the axes back on so you can see it more clearly. Let's see. Okay. All right. See how Z. See, and then there's Y is rolling under. It's spinning around X right now. Okay. All right. And then 2, it's rotating around the Y-axis. All right. It's going this way. And then 3, it's rotating around the z-axis this way. Again, like I said, all I'm doing is I'm changing the view of the art. I'm not changing the art. I'm just changing the way it looks on the screen. And you can see here the angle of rotation around each axis, right? So if you hit the digit 5, that pops you back to the front view of space. If you hit the digit 6, you're looking at the left side of space, which in this case is a 2-dimensional image. So there's something 3-dimensional. Digit 7, you're looking at the top of space. Okay. Digit 8 is similar to digit 4. Okay. 1, 2, and 3 cause the art to orbit on individual axes. There's X, there's Y, there's Z. Right? 4 rotates on all 3 axes at the same time, and you get this kind of interesting wobbling effect, which is kind of nice. It really gives you an idea of the fact that this is truly 3-dimensional. You can really see it when you do that. Okay, so again, 5 pops you back to the cardinal view, looking straight into space, right down the z-axis. 6 is the side, 7 is the top, and 8, if you press and hold it, it does... not only does it orbit like 4 does, but it also advances the frame, okay? And if you hit the shift key while you're doing any of these things, you get the opposite effect. So if I just hit 1, it's going to roll the art this way. And if I do shift 1, it's going to roll the art backwards the other way. If I do a 2, it's going to roll the art this way, and a shift 2 rolls it back the other way. Same as with option 3, which is much easier to see. We're going this counterclockwise. Shift 3, we're going clockwise. Okay? And then same holds true of the cardinal views. If I hit 5, I'm looking straight on into space from the front of it, okay? And then here it'll be a little easier for you to see what's going on. If I'm looking at, okay, I'm looking straight into space because I hit 5. If I hit Shift 5, I'm looking at the back of space. Like I've gone behind the cube and I'm looking into it that way. I'll show you what I mean. If I shrink the cube down a little bit and rotate it around, you can see, like, see, there's the front of it. I spin around, right? There's the front of it. And if I go all the way around, now I'm looking into the back of the cube. That's what Shift 5 does. It's the back of the cube. 6 is the left side of space, right? And Shift 6 is the right side, looking into the right side of the cube. 7 is the top of space, okay? And Shift 7 is the looking at the bottom of the cube up, okay? And then also another thing you can do is you can pan, which means, okay, I'll set this back to 5. Now we're looking at normal, no rotation whatsoever, okay? And we'll hit F to bring us back to, okay, I'm going to get rid of those right back into V. Okay. We can also offset our view, which means if you press and hold the Q, see it's moving, it's like panning that way. If you press W and hold it, it moves this way, okay? So like if you want to, if you're drawing something and you really want to see in detail what you're drawing, you can move the camera around and you can zoom into it as well, because here we have A zooms just the x-axis. So like if you import art and the x and y aren't quite proportional to one another, you can kind of fix the way it looks on the screen. Or you can use D, which zooms both x and y at the same time. So if I shift D, capital D, it zooms away. See, capital D is negative. So this is lowercase d is positive, capital D is negative, and it changes the appearance of the art without changing the art itself, okay? Now, if I do want to change the art itself using this view scenario here, I can do that. But I can only change one aspect of it at a time. Now, we have zoomed away from space, which is why it's a little bit smaller now. We just like moved the camera further away from it, so to speak. And we're at about, it's currently at about 47% of normal size. But we've also panned it over to the right and panned it up a little bit to the top. So you can see here we're 13,200 points to the left, or excuse me, to the right, 14,300 points up in Y. And these points here that are relative, again, to signed short integer space, because from the origin to the edge is 32,767 points, or the total width of this screen is 65,535 points. So we've moved it 13,200 to the right and 14,300 up, okay? Now, if I apply the scale, I can apply it to just this frame, which is the lowercase g, or I can apply it to the entire frame set with a capital G. So I'm just going to tap lowercase g and there. And now it applied the scale to the frame. And you'll notice the boundaries of space popped out again, because now our scale factor is back to 1, because it imposed the scale on the art, and then it said, okay, we're done doing the scaling thing, so now the zoom of the camera is normal. It's 1:1, and it's over here now. And now that I've applied the scale, I can apply the offset, T, just lowercase t applies to this single frame. Capital T would apply to all of the frames in the frame set. So I'm going to hit lowercase t, boom. See, now it's applied the offset to the art. Now our offsets are back to 0. Our scale is 1. And there's no rotation on around any of the axes. And we have, in fact, affected the art itself because this used to be bigger and it used to be in the center. So we shrunk it down and we moved it over here. And of course, you know, this works in three-dimensional space. This is a 3D thing, okay? But the reason, I'll show you here, the reason there's no scale for Z and there's no offset for Z because these numbers have to do with the way three-dimensional vector art is displayed on a two-dimensional raster screen. And on a two-dimensional raster screen, there is no Z. So panning left and right, up and down makes sense, but there is no pan in Z. You can zoom, which is more like, you know, which is like magnifying or demagnifying, if you will, the size of the art. That makes sense. But again, it only makes sense to zoom in and out on the X and Y axis because there is no Z axis on a two-dimensional display. However, if you're rotating, you're talking about you're rotating the camera around a three-dimensional object. So when it comes to rotating around a three-dimensional object, it makes sense that you should be able to rotate around all three axes because in this case, Z is relevant because you can rotate around it. Okay? All right. It's a little confusing, but you get used to it. Okay, so we've covered what you get in the Ilda folder. We've covered the fact that all your files need to happen in here. And we've talked a little bit about LaserBoy Space and what it is. LaserBoy is a memory object. It's a container. So it allows you to open a file, like an Ilda file, or a WAV file, or a formatted ASCII text file, or a DXF file, or a set of DXF files. You can bring that vector data into LaserBoy, into the LaserBoy memory space. LaserBoy can manage any number of frames that you have loaded, any number of palettes that are associated with those frames. It can display that information for you in a variety of different ways that I've kind of demonstrated here. And it also allows you to manage and manipulate that data, change the data, add to the data, draw into data, create new data, whatever. It's all done in the LaserBoy memory object. So this is a basic introduction to just getting into opening the application and kind of having a cursory understanding of what you're looking at.